If you are running Linux right now, on your desktop, your laptop, your home server, your cloud instance, your Raspberry Pi, your NAS, your anything, stop what you're doing and listen carefully. Because in the last 10 days, 2 separate critical vulnerabilities have been disclosed in the Linux kernel. Both of them allow any unprivileged user on an affected system, someone with a basic low-level account, no administrator access, no special tools, to escalate their privileges to root, full root, complete system control. Both of them have working proof of concept exploit code that has already been published publicly on the internet, meaning anyone with malicious intent can follow the published instructions and recreate the attack right now. The first one, called copyfail, affects Linux kernels distributed from 2017 through April 2026, 9 years of kernel releases. And the second one, disclosed just 24 hours ago, is called dirty frag. It was found in the same area of the kernel as copyfail. It works through additional attack paths, and reports are already emerging that it may also be under active exploitation. 2 critical kernel privilege escalation vulnerabilities in 10 days, a public exploit for both. CISA mandating immediate patching. This is not theoretical, this is happening. And if your Linux system has not been updated in the last few days, it is currently vulnerable to both. This video is going to tell you exactly what these vulnerabilities are, exactly how dangerous they are, and exactly what you need to do right now to protect yourself. Let us start with copyfail, because understanding it clearly is essential to understanding just how serious the current situation is. The vulnerability is tracked as CVE 2026-31431. It was publicly disclosed on April 29th, 2026. It was discovered in approximately 1 hour through an AI-assisted security research process, a fact that itself tells you something important about the changing pace of vulnerability discovery. The flaw lives in the Linux kernel's cryptographic subsystem, specifically inside a component called the algif AAD module, which is part of the AF-ALG interface, the user space crypto API that Linux exposes to applications. The underlying bug was introduced in a kernel commit from 2017. It has been sitting in the Linux kernel, undetected, for 9 years. Here is what makes copyfail so technically dangerous compared to most kernel vulnerabilities. Many privilege escalation exploits depend on race conditions, timing-based attacks where the exploit has to win a very narrow window of opportunity between 2 system events. Race condition exploits are powerful but unreliable. They succeed some percentage of the time and fail the rest, making them noisier and harder to deploy consistently. Copyfail is different. It is what security researchers call a deterministic logic flaw. It does not depend on timing. It does not depend on winning a race. It exploits a predictable, consistent logical error in how the kernel handles memory during in-place cryptographic operations. A single 732-byte Python script can successfully exploit it, without any modification, across different Linux distributions. You run the script, it works, every time, consistently. Across Ubuntu, Red Hat, Debian, SUSE, Amazon Linux, Alma Linux, and virtually every other major distribution running an affected kernel. That consistency is what elevates copyfail from a serious vulnerability to a critical one. What does exploitation actually look like in practice? An attacker first needs to obtain local code execution on a vulnerable system. That could be through SSH access to a server, through a compromised low-privilege account on a shared system, through a malicious CI/CD job in a cloud environment, through a container escape, or through any other technique that gets them running code as a non-root user. Once they have that foothold, once they have any account on the system, even a basic unprivileged one, they run the copyfail exploit. The exploit abuses a subtle flaw in how the kernel handles Linux's page cache during cryptographic operations. Rather than modifying files on disk, which would be detected by file integrity monitoring systems, it modifies the in-memory copy of privileged executable files like su and sudo. The files on disk remain completely unchanged. Your file integrity checker sees nothing wrong. But in memory, where those files actually execute, the attacker has substituted malicious code. They have gone from a low-privilege account to full root control of the system without touching a single file on disk. CISA, America's lead federal cybersecurity agency, added CVE 2026-31431 to its Known Exploited Vulnerabilities catalog on May 1st, 2026, 2 days after disclosure. Adding a vulnerability to that catalog is not routine. CISA does it specifically when there is confirmed evidence of real-world active exploitation by real threat actors. It also triggers a legal mandate. Every organization covered by CISA's binding operational directive, every U.S. federal civilian government agency, is required to patch immediately. CC added it with an explicit public message. It strongly urges all organizations, not just federal agencies, to prioritize timely remediation. Tech Republic's coverage summarized the situation plainly. The U.S. government's warning indicates that exploitation of this attack in the wild goes beyond employees trying to escalate their own privileges. External attackers are using this. Now take a breath, because just as the security community was beginning to fully digest copy-fail and roll out patches across their infrastructure, a second vulnerability was disclosed. It was published just 24 hours before this script was written. It is called Dirty Frag. It is tracked as CVE 2026-43284 and CVE 2026-43500. Its discoverers have nicknamed it copy-fail-2. It was found in the same region of the Linux kernel that produced copy-fail, the networking and memory fragment handling components, specifically involving ESP4, ESP6, and RxRPC modules. Like copy-fail, it allows an unprivileged user to escalate to root. Unlike copy-fail, it introduces additional attack paths that expand the ways exploitation can succeed and improves the reliability of privilege escalation beyond even the deterministic consistency of the original. Microsoft's security blog, which published detailed analysis of Dirty Frag on May 8th, confirmed that public proof of concept activity is already present and that exploitation may have already begun against real targets. Dirty Frag specifically affects environments that use IPsec VPN functionality, one of the most common VPN architectures in enterprise Linux deployments, because the ESP4 and ESP6 modules it exploits are frequently loaded by default in those environments. If your Linux system uses IPsec for VPN connectivity, and in enterprise settings a very large proportion do, those modules are almost certainly active and the attack surface is directly exposed. Microsoft Defender was already monitoring active exploitation attempts and investigating detections as of May 8th. Patch availability is still catching up to the disclosure. The patch has not yet propagated fully to all distribution-specific update channels, which means some systems running fully up-to-date packages on their distribution may still be vulnerable while they wait for their distribution's kernel update to arrive. Security Week described the situation in one sentence that cuts to the heart of it. The exploit was disclosed before a patch was released. That is the worst-case scenario in vulnerability disclosure. It means the window between attackers know about this and have a working exploit, and defenders can actually apply a fix, is not zero. It is however long it takes your distribution to package and distribute the kernel update, and however long after that it takes you to apply it. Here is what you need to do right now. We are going to go through this step by step for different types of Linux users, because the actions differ slightly depending on whether you are a desktop user, a server administrator, or someone managing cloud workloads or containers. If you are a desktop user running Ubuntu, Linux Mint, Zorin OS, Pop, OS, or any other Ubuntu-based distribution, open a terminal and run two commands. The first is sudo apt update. That refreshes your package list and tells your system what updates are available. The second is sudo apt upgrade. That downloads and installs every available update, including the patched kernel. After the upgrade completes, reboot your machine. The reboot is not optional. The patched kernel only takes effect after a reboot. Once your system comes back up, you can confirm you are running the updated kernel by opening a terminal and typing unaim er. If the version shown matches the patched kernel version for your distribution, which you can find on your distribution's security advisory page, you are protected. If you are running Fedora, open a terminal and run sudo dnf upgrade. Refresh, then reboot. If you are on Red Hat Enterprise Linux or CentOS Stream, run sudo dnf update and then reboot. If you are on Debian, run sudo apt update followed by sudo apt full upgrade and then reboot. OpenSUSE users should run sudo zipper refresh and then sudo zipper update followed by a reboot. In every case, the critical step is confirming that the kernel itself was updated, not just the applications. After your reboot, run unaim er and compare the output to your distribution's published advisory to confirm you are on a patched version. If you are running a Linux server and cannot immediately apply a kernel update and reboot, because your environment requires change management processes, maintenance windows, or staged rollouts, there's an interim mitigation for copy-fail. You need to disable the vulnerable algif-i kernel module. To do this, run the following command as root: echo install algif out add -bin false etc. modprobe. Disable algif conf. This creates a configuration file that prevents the vulnerable module from loading. Then run sudo modprobe ralgif aed to unload the module from the currently running kernel if it is already loaded. This mitigation stops the copy-fail exploit path without requiring a reboot. For Dirty Frag, interim mitigation is more complex. If your environment does not require IPsec VPN functionality, disabling the ESP4 and ESP6 modules removes the primary attack surface. Microsoft's security blog published specific commands for evaluating and implementing these mitigations. Check their May 8th Dirty Frag advisory for the exact syntax applicable to your environment. Be aware that disabling IPsec modules on a system that actively uses IPsec VPN tunnels will disrupt those connections. Evaluate this carefully before applying it in production. If you are managing cloud instances on AWS, Azure, Google Cloud, or any other provider, check whether your cloud provider has published an advisory or automated remediation for copy fail and dirty frag. Amazon Web Services, Google Cloud, and Azure all have mechanisms for pushing kernel updates to manage Linux instances, but not all of these updates happen automatically. Many Cloud Linux instances are configured to require manual approval for kernel updates because kernel updates require reboots, and reboots interrupt running services. Go to your Cloud Console right now and check your update status. If kernel patches are available and pending, schedule a maintenance window and apply them as soon as operationally possible. Carnegie Mellon University's computing facilities, which published their response to copy fail on April 30th, noted that systems without endpoint detection and response tooling were being prioritized for remediation because of reduced visibility into potential exploitation. A reminder that unmonitored systems are the highest risk targets. If you are managing Kubernetes clusters or containerized Linux workloads, the risk picture has an important nuance that Microsoft's security analysis flagged specifically. Because the Linux kernel and its page cache are shared across an entire node, shared between the host system and the containers running on it, a successful copy fail or dirty frag exploit within a container can compromise not just the container, but the entire host node. An attacker who achieves initial access through a container escape, through a malicious CI/CD job, or through any low-privilege account in your Kubernetes environment can use these vulnerabilities to escalate to root on the host. Microsoft's recommendation for Kubernetes environments is explicit. Treat any container remote code execution as a potential host compromise. After applying patches, consider node recycling for any Kubernetes nodes that were exposed before patching. Do not assume that container isolation protected you from a kernel-level privilege escalation exploit. Now let us step back for a moment and look at the bigger picture, because there are two things about this situation that are genuinely important to understand clearly. One that is alarming, and one that provides real perspective. The alarming thing first. 2 critical privilege escalation vulnerabilities in the Linux kernel in 10 days is not normal. The Linux kernel has a strong security track record compared to many commercial operating systems. Its open source development model means that thousands of eyes review code constantly, and vulnerabilities are generally found and fixed more quickly than in proprietary code bases. But the discovery of both copy fail and dirty frag in the same subsystem of the kernel, within days of each other, suggests that the security research community, and potentially threat actors, are focusing intensive scrutiny on this part of the codebase right now. The fact that copy fail was discovered in approximately 1 hour through AI-assisted research is particularly significant. It means the pace of vulnerability discovery is accelerating in ways that defenders have to keep up with. The AF-ALG cryptographic interface and related kernel networking components are now known to contain at least 2 severe logic flaws. There may be others in adjacent code that have not yet been discovered and disclosed. CISA's decision to add copy fail to the known exploited vulnerabilities catalog within 2 days of disclosure reflects an assessment that this is not a theoretical risk. Real threat actors, criminal ransomware groups, state-sponsored intrusion teams, opportunistic attackers scanning the internet for vulnerable machines, have this exploit and are using it. The 732-byte Python script that implements the copy fail exploit is simple enough that it does not require advanced offensive security expertise to deploy. Anyone who can run a Python script can use it. Now the perspective, because the Linux security model, even in the face of these vulnerabilities, has structural advantages that are genuinely important and that the current situation demonstrates clearly. The open source nature of the Linux kernel means that when vulnerabilities are found, patches arrive fast. The upstream Linux kernel stable branches already contain the fix for copy fail, and distribution maintainers moved quickly to package and distribute it. Cloudflare, which operates global Linux infrastructure across 330 cities, published a detailed post-incident analysis of their copy fail response that shows exactly what rapid, well-prepared Linux security response looks like. Their security team began assessing the vulnerability as soon as it was disclosed. They validated that existing behavioral detections could identify the exploit pattern within minutes. They searched 48 hours of fleet-wide kernel logs for signs of pre-disclosure exploitation. They deployed a runtime mitigation using BPF LSM that protected their entire fleet without requiring a single reboot. And they rolled out patched kernels immediately afterward. No customer impact. No data at risk. No service disruption. This is what good Linux security practice looks like in action. It is a model worth studying and emulating. The same transparency that made both vulnerabilities public, with full technical details and working exploit code, Also made the patches public, made the mitigations public, and created intense public pressure on distribution maintainers, cloud providers, and organizations of every kind to act immediately. Compare this to the Windows CVE 2026-32201 SharePoint Zero Day from the April Patch Tuesday, which was being actively exploited before a patch was available, with a narrower window of public scrutiny and far less community-generated pressure for rapid enterprise response. Open source security is not perfect security, but its transparency creates accountability that proprietary systems cannot replicate. Here is the final honest check you should do after applying your kernel updates. Confirm the update took effect. Open a terminal and type unaim r. Look up your distribution's security advisory for copy. Fail to find the exact kernel version number that contains the fix. Ubuntu's advisory is at ubuntu.com for security CVE 2026-31431. Red Hat's is at access.redhat.com for security CVE 2026-31431. And similar pages exist for every major distribution. If the version shown by uname r matches or exceeds the patched version in the advisory, you are protected against copy fail. For Dirty Frag, check your distribution's advisory for CVE 2026-43284. Patched kernels for this vulnerability are still rolling out as of May 8th, so check back if the patch is not yet available for your distribution and apply it the moment it arrives. Also check whether the algif aead module is loaded on your system by running lessmod grep algif yadd. If output appears, the module is currently active. On a patched system, this is fine. The vulnerability is fixed. On an unpatched system that you are temporarily mitigating, this module should be disabled using the modprobe command described earlier. And finally, read this as both a warning and an encouragement. The Linux security community's response to copy fail over the last 10 days has been fast, transparent, technically excellent, and publicly documented. The Cloudflare post, the Palo Alto Unit 42 analysis, the Carnegie Mellon advisory, the CISA known exploited vulnerabilities listing, the distribution security advisories published within hours of disclosure. All of it publicly available, clearly written, and actionable. The Linux security ecosystem works, but it only works for you if you apply the updates it produces. An unpatched Linux system is not a secure Linux system. It is a Linux system with a 732-byte Python script waiting to hand someone root access to everything you own. Update now, reboot, confirm. Then you can breathe again,